let's talk about one of the most insidious threats hiding inside your AI systems right now: backdoor attacks. We're talking about a model that aces every single one of your tests, looks absolutely perfect, but has a secret master key an attacker can use at any moment. So how does this even work? And more importantly, what can you do to stop it?
You know, this analogy really hits the nail on the head. Think about it. You hire a new employee. They're a star performer, perfect in every way. But they have a secret, hidden instruction. If anyone ever says a specific code word, their entire mission changes, and they start acting maliciously. That's exactly what a backdoored AI model is, a sleeper agent hiding in plain sight. So, to put a finer point on it, a backdoor isn't some temporary glitch. It's a permanent vulnerability that's been deliberately baked into the model. Under normal circumstances, you'd never know it's there. But the moment an attacker presents a very specific secret trigger, it could be a weird phrase, a logo in a picture, anything really, that hidden malicious behavior snaps into action.
Now, you might be thinking this is some kind of theoretical sci-fi problem. It's not. This is a clear and present danger. And at its heart, it's a massive supply chain risk that's affecting companies deploying AI today. The numbers really tell the story here.
A staggering 80% of organizations, that's 4 out of every 5, are using pre-trained models they downloaded or data from external sources. And look, that makes sense. It's efficient. But every single one of those external assets is a potential Trojan horse, an entry point for an attacker to sneak a backdoor into your systems. It creates this huge and, frankly, often unmonitored attack surface.
And this isn't happening in a vacuum. This trend is running in parallel with the absolute explosion we've seen in traditional software supply chain attacks, up over 700%. But here's the scary part. With AI, the malicious payload isn't in some line of code you can find. It's buried deep inside the millions of mathematical weights of the model itself. It's almost invisible.
And if you think, well, we'll just scan for it, I've got some sobering news. DARPA, the advanced research agency for the U.S. military, ran a whole program to build tools to find these things. The result? Even their most sophisticated tools failed to find the backdoors 70% of the time. That just shows you how incredibly difficult this detection challenge really is.
Okay, so how do these things actually get into our models? Well, attackers have a playbook, and it really comes down to 2 main strategies. Each one targets a different part of your AI supply chain.
On one hand, you have data poisoning. This is where the attacker taints the well. They corrupt the very data the model is trained on. The model then learns the backdoor naturally as part of its education. On the other hand, there's model modification. Here, an attacker takes a perfectly good pre-trained model and performs surgery on it, implanting the backdoor after the fact. The big takeaway, you have to secure both your data supply chain and your model supply chain.
This is the question I hear all the time, and it's absolutely critical. You're looking at your dashboard, and it says 99% accuracy on all your tests. So that means it's safe, right? It passed with flying colors. It's a perfectly logical assumption, but it's also a trap.
And the answer is a hard no. Your standard tests are completely blind to this threat. Why? Because your test data doesn't have the attacker's secret trigger in it. The model was literally designed to act perfectly on all the normal expected data you'd throw at it. Relying on those accuracy scores alone gives you a totally false and very dangerous sense of security.
Okay, so the problem is serious. It's sneaky, and our usual tests won't catch it. So what on earth do we do? Well, the solution isn't a single magic tool. The answer is a strategic 4-layer defense-in-depth approach. Let's walk through what that action plan looks like. We break this down into 4 logical layers. It starts with prevention, locking down your supply chain and making sure your training process is clean. Then it moves into active detection, with specialized scanning before you ever deploy a model. And finally, it ends with continuous monitoring while the model is live. They all work together. You really need all 4. So layers 1 and 2 are all about prevention. This is your foundation. First, you have to know where your models are coming from. Verify their provenance. And then use cryptographic signatures, which are like a digital tamper-proof seal, to ensure they haven't been messed with. Second, you have to do the same for your data. You need robust validation and the ability to trace the lineage of every single dataset. Now, layers 3 and 4 are about assuming you might miss something and being ready to detect and respond. Before any model goes into production, you've got to scan it with specialized tools built to hunt for these hidden triggers. Once it's live, your job's not done. You need runtime monitoring to spot bizarre behavior. And, of course, you absolutely need an incident response plan. What do you do the moment you find one? How do you isolate it, roll back, and retrain?
I know what you're probably thinking. This sounds like a lot of work and investment.
So let's get right to the business case, because this isn't just some technical checklist, it's a bottom-line issue that hits compliance, cost, and your company's hard-won credibility.
Let's start with the cost. The data from the Ponemon Institute is just crystal clear on this. Proactive prevention costs, on average, 5 times less than cleaning up the mess after a breach. The ROI on putting these defenses in place up front is undeniable compared to the panic and expense of finding out you've been exploited.
And then there's the compliance hammer. New regulations like the EU AI Act are coming, and they have teeth. A backdoored model is, by any definition, a manipulated AI system. If that system is considered high risk, you could be looking at fines up to 35 million euros, or even 7% of your global revenue. Suddenly, the cost of doing nothing looks pretty terrifying.
So let's just quickly boil this all down. Number 1, backdoors are secret master keys hiding in models that look perfect. 2, the risk is coming at you from 2 directions, your data and your models. 3, those standard accuracy tests you love, they're giving you a false sense of security. And 4, the only real answer is a multi-layered defense. No single tool is going to save you.
I want to leave you with something you can use the minute this is over. Here are 4 essential questions you need to be asking every single one of your AI vendors. Can you prove where this data came from? How do you know the model is clean? Have you actually scanned for backdoors? And what's your plan when something goes wrong? Their answers, or their inability to answer, will tell you everything you need to know about the risk you're inheriting.
And that really brings us back to the core question you need to be asking inside your own organization. Your AI model looks perfect, it's performing beautifully, but have you thought about the one secret question, the one hidden trigger that could bring the whole thing crashing down? Finding that trigger before an attacker does, that's the name of the game in AI security today.